Yes, yes.
So a rectangular sheet of metal, 72 cm by 84 cm. A rectangular sheet of metal, 72 cm by 84 cm. So 72 cm by 84 cm. Has squares. Squares. Each of side ycm. Has squares. Each of side ycm. Cut off from its corners. Has squares. Each of sides ycm. Cut off from its corners. 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 The remainder is then formed into a cuboid of volume v cm cube. The remainder, after cutting it, the remainder is then formed into a cuboid of volume v cm cube. The remainder is then formed into a cuboid of volume for v cm cube, or volume v cm cube. The remainder is then formed into a cuboid of volume v cm cube. v cm cube. Find the value of y. Find the volume of y. Find the value of y. Find the value of y. For of which find the value of y for which the volume of the box will be maximum volume of the box. Find the value of y for which the volume of the box will be a maximum volume of the box, and hence the maximum volume. So find the value of y for which the volume of the box will be the maximum volume of the box, and hence the maximum value itself. And hence the maximum value itself. So let's just do some distance. So solution. Let's look at how it is. So from here we are going straight to how to draw this thing, curves. Solution. So that let me first see if I can draw. So we have something like this. I don't want to draw it exactly so that you see how it is. So we have this. Sorry, it's the network. So we have this was what I was using. I'll just do it fast. So according to the question says that a rectangular sheet of metal. So this is a rectangular sheet of metal. I was supposed to this thing, but this looks like a square, but let's take it as a rectangular sheet of metal having 72 by 84. So definitely here will be the 84 and here will be the 72. So we assume that from here to here is 84. And from here to here is 72. Now the question states that by 84 cm has squares each of side y cm. So it has a square. So this is the square of each side. This is the squares of each side. These are the squares of each side. And these squares are cut off from its corners. And so this the side here is y. Here is y. The sides are given by y, and they are cut off from each side. So you assume that there's y will be cut here, and y will be cut here. Okay. The dimension. So the remainder is then formed into a cuboid. So after cutting this and this and this, the remainder, which will be definitely this, will be this, and this part, is used to form a cuboid. That is it. Now the remainder is formed into a cuboid of volume VCM cube. So we are going to find the volume of a cuboid. So definitely now we know that the volume of a cuboid will come into play. Then and so on. Now find the value of y for which the volume of the box will be a maximum volume of the box, and hence the maximum volume. Now the first thing we are going to do is we are going to first find for the dimensions of the net cuboid. So when you say net cuboid, that means the total cuboid. That is it. Before this and this were cut off. And so looking at this, if this is cut, if this side and this side is cut off, then the dimension here will be 72. Will be the dimensions we are going to get 72 minus 2y. That will be our first dimension. So the dimension here, if you want to get the dimension from here to here, then it will be 72 minus the 2 cuts off. And we are also going to get another dimension. The dimension on top here to be what do you call it? The dimension on top here to be 84 minus 2y minus 2y. That will be another dimension. Now then, so the dimensions of the cuboid formed will be that one, and YCM to be one and another dimension. YCM. That is YCM will be another dimension. So this is one dimension. This one will be another dimension. This one will also be another dimension. And so YCM is this one. This one is 72 by minus this, and 84 minus this. So this will be our 3 dimensions. After looking at our 3 dimensions, then you can be able to find for the volume. So our volume, the volume of the cuboid is, the volume of the net cuboid will be equal to this. Will be equal to, you know, volume is this by this by this. It's 3 dimensional. And so we are going to get into bracket 72 minus 2y by into bracket 84 minus 2y into bracket YCM, or into bracket y. Now when we multiply it, what will be our volume? What will be the volume? The volume of the cuboid. What will be the volume of the cuboid? Oh, someone should do the math and let me know. So I'm going to get 6048 y minus 312 y squared, 312 y squared plus 4y cube. So that's what we are going to get. Now from here, then we can do our mathematics. So the first thing you have to do is we are now coming to the maximum and the minimum. So this is our general equation. We've been able to use the deduction from this to form an equation, so getting a volume. So the question says we should find for the value of y for which the volume of the box will be maximum volume. And so we are going to differentiate the volume with respect to y. Divine all over the y. That will give us what will we get? That will give us 6048 minus, what are we getting? 624y plus 12y raised to the power 2. That's what we are going to get. Please, do you get it? So at the stationary point, dv, we equate dv all over dy to be equal to 0. So when you equate the whole of this to be equal to 0, what are you getting, please? So this will be 0 is equal to 6048 minus 624y plus 12y squared. What are you getting, please? Y will be equal to what? When you use your calculator, what will we get for y? Y will be equal to? So when you use your calculator, y should be equal to 39.12, and y will also be equal to 12.89. We want to know whether they are maximum or minimum values, and so we want to know whether they are maximum or minimum values. So we are going to differentiate this one again. So we are going to find the square vein. The square vein all over the y squared is equal to, now when differentiated, this will go away and it will be left to this. So this will be it's going to be 24y minus 624. I hope my distance is correct. 624. Now we want to find for that's what we are going to get. After getting this, we are going to what do you call it? So when y is equal to 3 point distance, when y is equal to this, what are you going to get for the square distance? We are going to substitute y into them to know whether v will be minimum or v will be maximum. So when y is equal to, when we substitute y here, now we have y here. When we substitute, this network power too. So now we have two y values, but we have to check which of them constitutes or which of them will give us a maximum value. And so the first y value we had was 39.12. The second one was 12 point something. That is 12.89. Now 89. Now before we can be able to find whether they are the same, unless we differentiate it again and get a second derivative. So dv squared all over the y squared should be equal to, what did we get? We have 24 minus 24y minus which number did we get? 624. But looking at the question stated that find the value of y. So now we have two y's. We have to check each of the y's, which one will give us a maximum value, or which one will give us a maximum value, or which one, when after putting in place of this one, will give us something lesser than 0. So that's what we are going to do. So we first up to the first one. When it's up to the first one, the v squared all over the y squared is equal to 24 into bracket 39.12 minus 624. What will we get? Dv all over dy. What are you going to get? I'm going to get I won't get what? 315. So 315.
Yes.
And looking at 315, before we can be able to know that this one is a maximum value, then that means what you are getting here should be greater than, should be less than 0. But here this one is greater than 0. So we can say that this one is not what you are looking for, but the question says we should find for the y, which is which is the maximum or something. So you put this one to here and see if you can get a minimum value. We can get it in the negative. So the v all over the y squared is equal to 24 into bracket 12.89 minus 624. What are you getting?
Negative 315.
So negative 315. Negative 315. So that means for this y value, we can get a volume which is a maximum volume, right? And so that means our y value is what you are looking for, because this y value, according to the question states that find the value of y for which the volume of the box will be maximum volume. And so you realize that the y for which the volume will be a maximum volume will be this y. I hope you are getting it to that point. Are you getting it, please?
Yes, sir.
So now to find for the maximum volume itself, we know that right from onset, we know that v, after doing this thing, we know that v, we are given v to be equal to what? Right from onset, v was given as 6048y minus 312 y squared plus 4y cube. So now we are looking for, now we know that when we put this one is the maximum, this is the y for which the volume will be maximum. So we factor this x value, this y value into it to come and get our maximum volume. So v will be equal to 6048 into bracket this one. So what are you going to get? So 6048 into bracket 12.89 minus 312 into bracket. Please use do the computations and let me just write the answer. So then will give us what is it? What is it? So y is equal to v is equal to, what are you getting, please? Oh, use your calculators. Substitute this value into this. So we are going to get the volume will be equal to 34689 I think .07 cm cube. So this will be the volume we are talking about, the maximum volume we are talking about, because the y is the maximum value, because it gave us negative 315, which is less than 0. So then we use this y instead of this, because this one is giving us a minimum value. If the question said a minimum volume, then that means we would have used this one. And because the question is a maximum, then that means we are going to use this one. I hope you are okay. I hope you are cool with it. So when you're given the question, you have to take your time and digress the question better and write the equations. It's a little bit dicey, but if once you're able to come up with more or less like a problem, story problem, once you're able to come up with a good equation, and the rest is your normal thing I've taught you. You just differentiate with respect to the y. If it is dx, if it is dt, you do it. You equate it to 0. You find the values and so on and so forth. You come and differentiate again, and based on the question, you should be able to do it. I hope I've made myself clear. So now let's do.
Yes.
What time have we left it? Someone should check the time. I left it. I want to do a new topic again. So I'm going to do curve sketching. Okay, curve sketching. That'll be our last topic for today. Curve sketching. Curve sketching. That is very simple. This one is very simple. Or that I do something. I told you that when you have something like this, I'm going to get something like this. Okay. So when we have something like this, or that I do it. So you bear with me that if here is point N and here is point P, and you can bear with me that here is positive, here it is decreasing, so here will be negative. So from here to here, we are saying that the curve is increasing. So this curve is increasing. Now when you get here, we are saying that the curve is decreasing. I hope you get it. So let's say Q, here is R. So then definitely it will come here. So when it is coming to be positive, that means it will be something. No, like from here to going up here to be increasing, and when it's coming down, then it will be decreasing. So the function of y is said to be increasing if the derivative is positive. And so here it can only increase if the derivative is positive. That means if dy dx is greater than 0. If dy dx is greater than 0, then we are saying that it is increasing. Now, if dy dx is lesser than 0, then that means we are saying that it is the dy dx is the gradient too. Don't forget that dy dx is gradient. Changes in y all over changes in x. If it is greater than 0, then that means it is climbing. And we are saying that the curve is increasing. Now, if it is lesser than 0, then we are saying that the curve is decreasing. And so that is it. So the line from here to here is increasing. From here to here is decreasing. From here to here is increasing. Definitely when it's coming down, it will be from here to here is increasing. From here to here will be decreasing. Basically, that is it. Now, let's try one example. Find the range of values of x for which the function y is equal to 2x cubed minus 9x squared plus 12x plus 3 is increasing. So we want to find for the ranges of values, because you know definitely there's a range. From here to here, there's a range. That's the difference. So find the ranges of values of x for which the function y is equal to 2x cubed minus 9x squared plus 12x plus 3 is increasing. And so we are given the equation is y is equal to 2x now x is a power 2 plus 12x plus 3. That is it. So y is equal to 2x cubed minus 9x squared plus 12x plus 3 is increasing. So the question is that you should find for the range of values of x for which the function y is equal to 2x cubed minus 9x squared plus 12x plus 3. And so the first thing we are going to do, the question is that we should differentiate with respect to x. So dy dx is equal to, what are you getting, please? Dy dx will be equal to what? 6x. Oh, please talk to me. We are all doing it together. 6x 6x squared. 6x squared minus, this will be 18, right? 18x plus 2. Oh, I'm lying. Plus 12. Plus 12. So we want to find the ranges. So the question says that when dy dx is greater than 0, so dy dx slash dx, if it is greater than 0, then that means it is this. And so let's equate dy dx being greater than 0. And so I wish I had this. So we are going to get something like this. This is inequalities. So 6x squared, this will be 6x squared minus 18 plus 12. If it is greater than, let me see if I can get the greater than sign. If it, that means you are saying that if the y, so don't forget that this one is the y dx, is greater than 0, then that means you are saying that it's an increasing curve or something, or it is increasing. So please, let's do it. Let's do the mathematics of this. What are you getting? S is equal to, so I'm going to get x minus 1, x minus 2.
2x.
Are you getting it? So x minus 1 greater than 0. X minus 1 greater than 0. So x minus 1 is x minus 1 greater than 0. Let us check. It will be x. It will be x is greater than 1, right? So solving it inequality, we have x is less than 1 or x is greater than 2. Please check for me. Check for me. So we have x minus 1, x minus 2 greater than 0. So we can first do this one, x minus 1 and 0. Then we can also do this one. What do you call it? So I'm coming, please. Minus 2. So I'm going to get so the values for which x is this thing is x. I'm coming. I want to get something. So we are going to solve this one inequalities. That's what basically what we did. And so we are going to get x. Those who solved it well, what did you get, please? Did you get the same thing? X minus 1, x minus 2. Did you get x minus 1, x minus 2? Please check for me.
Yes, sir.
So hence the range of values. So the range of values you are going to get is x is less than 1, x is greater than 1 is greater than x, and x is greater than 2. But the question says that if it is increasing, then that means the y dx should be greater than 0. So you can see that both the 2 and 1, they are all greater than 0. Or hello.
Yes,
So
sir.
both 1 and 2, they are all greater than 0.
Yes,
so that
sir.
means the curve is increasing.
Yes, sir.
I hope you are getting it. Now, however, if you solve it and they are all
Yes.
less than 0, then that means the curve is what? Decreasing. Do you get it? That means if you have to be getting it in negative, that means you can see the curves are decreasing. Are you getting it? Please, do you get it? So, if the question was to say that, find for the interval within which the function f of x is equal to 2x cubed plus 9x squared minus 24x plus 7 is decreasing, then that means when you solve it, you are supposed to get them in negatives. Now, when you get them in negatives, then that means it is increasing. Now it is decreasing. Are we there? Hello, are we there?
Yes, sir.
So
Yes,
now
sir.
let's do some quick distance. I want to finish it before we close. How to draw the curve. It follows 3 steps in drawing the curve. Now, we first have to find for the stationary points, following the procedure described above. So we already know how to find for the turning point. Then from there, we determine the nature of the turning points. Are the turning points maximum or minimum values? Then from there, we determine the intercept on the axis. So when we say the intercept, when we are talking about the y-intercept, we are going to put x is equal to 0. When we are talking about x-intercept, we are going to put y is equal to 0. So let's quickly do one, and we are done for curve sketching. We have 3 minutes. Let me just try to. So sketch the curve y is equal to x squared minus 4x plus 3, indicating all its turning points and intercepts. And so the question says that we should find for. I'll be a little bit very fast. But I want to finish. Y is equal to x squared minus 4x plus 3. So that's the curve we are given. So we first find for dy dx. We are finding for a turning point. What is dy dx? Give it to me fast. So that will be 2x minus 4. Am I correct? 2x minus 4. So we equate it to 0. When we equate it to dy dx to 0, we are found for the turning point. What are you going to get? X will be equal to 2. Unless I'm wrong, x will be equal to 2. And so now we go and substitute x into y to come and get its corresponding y value. And so when you put 2 here, what are you going to get? Y will be equal to, when you put 2 here, 2 in x, what are you getting for y? -1, right? So now so our turning points PNT is equal to 2 and minus 1. Oh, sorry. 2 and minus 1. Now from there, the second one says that we have to determine the nature of it. So we are going to find the second derivative of it to know whether it's a maximum or minimum. So second derivative of this one, we are going to differentiate this one. What are you going to get? I'm going to get 2, right? And 2 is greater than what do you call it, 0. So this one is a minimum point. dy squared all over dx squared is greater than 0. So it will be these points are minimum points. So minimum points are the 2 and 1. 2 / -1. I hope you get it. Now from there, the steps also says we should find for the intercepts. And so if you are finding for for y-intercept, int for y-int x is equal to 0. So when we put x is equal to 0 in this, when x is equal to 0 in this, what are you going to get for y? What are you going to get for y? When you put x is equal to 0 here, what are you going to get for y? I'm going to get y to be 3. Now, when we do that for the x intercept, what are you also going to get? S intercept. That is y is equal to 0. When y is equal to 0, what are you going to get? You're going to get 2 values. I'm going to get x minus 1 and x plus 1. In other words, we are going to get 1 or 3. X minus 3. So we are going to get 2 values to be y and 3. When we finish, then we are going to plot them. So we are first going to plot our turning points. So our turning point will be 2 minus 1. So we are going to plot the turning point. When we finish, then we come and plot the intercepts. And so the intercept, this one will be 0, 3. This one will be 0, 1, 0, 3. We plot all of them. Then we are done. I hope you get it.